Hi, I'm Samidha, an MSR student in the Department of Computer Science and Engineering at IIT Delhi. Today I'll be talking about a AAAI 2023 paper, Task and Model Agnostic Adversarial Attack on Graph Neural Networks. In the past few years, multiple kinds of GNNs have been proposed and they have been used to solve different kinds of predictive tasks. However, GNNs are vulnerable to minimal perturbations in the network structure. To illustrate, we take the example of this e-commerce network represented as a bipartite graph of buyers and products. Here, the GNN recommends the sofa for the lady and the set of books for the child. Suppose an attacker attacks this network and adds these two edges. Now the GNN's recommendation changes. This is undesirable. In this work, we design an adversarial attack assuming no knowledge about the task or the victim model in a targeted black box evasion attack setting, which I will describe in the following slides. Intuitively, a company can use a given input graph for multiple predictive tasks and they can use any kind of GNN model. We want to study if we can create a generalizable attack that is effective in all these scenarios. Targeted attack aims to reduce the performance of a model on a set of specific nodes or edges. Moving on, a black box attack assumes no knowledge of the GNN model, its parameter, the architecture, or the task it was trained for. Further, evasive attacks are done at test time on the input graph. The aim is to drop the performance of a deployed model maximally on the perturbed graph. The problem of adversarial attack on a GNN model M can be formulated as an optimization problem that tries to minimize its performance Pm on the perturbed graph G' for task T such that the number of perturbations are bounded by the budget B. To this end, we propose TANDIS, Targeted Attack via Neighborhood Distortion, the first ever task and model agnostic adversarial attack for graph structured data. TANDIS perturbations are found using reinforcement learning that maximize the neighborhood distortion. In a GNN, a node's representation is learned by performing convolution operation on its neighbors. Consequently, distorting the neighborhood should result in dropping the model's performance. We define neighborhood distortion as the Jaccard distance between the k-hop neighbors of a node T in the original and the perturbed graph. But maximizing neighborhood distortion under a budget constraint is NP-hard. Therefore, we relax the previous formulation and try to find distortion in the embedding space. For this, we embed the perturbed graph using an unsupervised GNN and attempt to increase the distance between the embedding of the node and its original neighbors and bring other nodes in the network closer to this particular node in the embedding space. Finding neighborhood distortion, as described in the previous slide, is computationally expensive because we need a embedding for each possible perturbation. Therefore, we approximate it by training a parameterized neural network using deep Q learning. At test time, optimal perturbations are found greedily from the inferred score from the trained neural network. To test the efficacy of TANDIS, we perform evaluation on multiple tasks, victim models, and datasets and compare with state-of-the-art baselines. Results. For link prediction task on Cora dataset, we see TANDIS in blue outperforming the best baseline GF attack by up to 2.5x in terms of drop-in accuracy. Similar trends were seen for pairwise node classification and node classification tasks. In terms of inference time comparison, TANDIS is more than 3x faster than GF attack for the largest dataset PubMed, and also the growth rate of inference time with increasing budget is much lower for TANDIS. Finally, we also conduct an experiment to study if TANDIS can be easily detected using common graph level properties. However, we found that edges selected by TANDIS only showed weak correlations, with these measures showing significant only 3 times out of 8. In particular, TANDIS is somewhat likely to perturb a node pair with a lower attribute similarity, a lower degree, and a higher local clustering coefficient. These weak correlations open up interesting avenues for future investigation and detection mechanisms. In summary, we design a task and model agnostic adversarial attack on graph neural networks. We use the idea of neighborhood distortions learned via reinforcement learning, and we conduct extensive experiments to prove the efficacy of our method. Thank you. For more details, please look up our paper at the QR code given below.